Okay, our next speaker, and I'm moving now into the energy level of this session, is Adam Scott. Let me just briefly introduce Adam. Everyone knows Adam, I think. Adam has been with the lift industry for over 31 years, and he's spent his time with the industry from Otis to Sweco. Currently is with, and he has been working on the design of vertical transportation system for many landmark buildings. So thank you very much, Adam, for being with us. And thank you, Adam. Over to you.
Thank you, Stefan. Good morning, everybody. I'd like to open with an apology for being the first male presenter without a tie on. I had breakfast with Nick Maller and Dave Cooper, and we both agreed that the occasion merited a tie. I then got back to my room and tried to put my tie on, and it would appear that my COVID diet means that my shirts have shrunk. So I'm casting a bigger shadow than I was the last time I saw you. I clearly need to consume a little less energy and expend a little more energy. And on the topic of energy, I'm going to chat a bit about energy efficient buildings and what part the lift industry needs to play in improving the efficiency of buildings. I think we're all far too aware of the events that are occurring on our planet. You know, this year, we've seen wildfires in California. We've seen 40 degrees centigrade heat in London. We've seen floods. I think this week in Tokyo, they had a dramatic 75 centimeters of rain in a 24-hour period. Centimeters of rain. Climate change is becoming real for all of us. And yet we continue to have to burn fossil fuels. We're creating a lot of pollution in our environment to feed the economy that, of course, contributes to the quality of life that we all enjoy. And there's a delicate balance to be struck somewhere. We see trends like this graph here that talks about urbanization and the fact that as a society, we have millions and millions of people urbanizing and moving into cities. And underlying it all is this kind of data that we're all very familiar with now of temperatures going inexorably up and up and up, fueling the climate change events that we're seeing more and more frequently. So what should our response be? I mean, I don't want this to be a downer session in the morning of day one. I think that urbanization statistic clearly says to us that we're going to see a lot more of these. Yeah. So this is Tokyo at the moment, and the sheer number of people that are predicted to go into urban environments is going to need many, many more buildings. This is a quote from the World Green Building Council. And this is current data. So it says buildings are currently responsible for nearly 40% of global energy-related carbon emissions. 28% from operating the buildings, so heating them, cooling them, powering them in other ways, and then 11% from the actual materials and construction. Nearly 40%. Now, I don't know, like you, I read lots and lots of data around energy, and there seems to be all sorts of maybe slightly conflicting data. But I think the key messages remain the same, that the built environment consumes a significant amount of energy, and it's worthy of our attention to try to reduce it. Particularly when we look at another stat from the World Green Building Council that suggests towards the middle of this century, so what's that, 30 years away? Yeah, less, 28 years away. The world's population approaches 10 billion. The amount of buildings in the world is going to be twice what it is today. But it feels a bit tricky, doesn't it? As I sit here as in our lift industry in the UK, and I struggle to see the wood for the trees. I mean, how can we contribute to solving this problem? And there is a framework. Yeah, many of you in the audience may be familiar with this. We've been doing a lot of work with our environmental engineers within our Sweco business, and they've given me some guidance and information on some of the framework that helps us, I guess, think about how we might address this problem. These are the United Nations SDGs, the Sustainable Development Goals, and these were agreed amongst many nations quite a period of time ago now as being the fundamental keystones of a sustainable world that will sustain us all. Number 11 there talks about sustainable cities and communities, and is the piece probably most closely associated with the industry that we work in. But buildings are ferociously complicated things, as we know. I mean, we're involved in one element of them, the lift systems. You know, there's some 3D models here on the screen, you know, that start to illustrate the complexity of structure, facade, mechanical systems, electrical systems, and of course, sitting in there is lift systems. And the manufacture, shipping, installation of all these systems produces damaging carbon dioxide emissions. And reducing the volume of CO2 emitted during the lifetime of any of these systems has got to be our ultimate goal. And the environmental engineers will talk about this thing called LCA, life cycle assessment, which is a circle that starts in manufacturing or raw materials, manufacturing, shipping it, installing it, the lifetime of the building or the system, the end of life, and recycling. And I think we start to then see how that plays into the world that we work in the lift industry, because we recognize that cycle of raw material manufacture, install, operate, recycle. But where could we start as a lift industry? Well, this piece about carbon, you may be familiar with the term whole life carbon, WLC, and that comprises two fundamental components. The first is embodied carbon. So this is about the materials that you actually create or manufacture. And it's the total CO2 emitted in producing those materials, estimated from the energy used to extract and transport them, as well as the manufacturing process itself. So an important element, embodied carbon. And the other piece that we're probably a little more familiar with in the operational side of the lift industry is operation. Yeah, as the lift goes up and down the building, it is consuming energy. And the graphic on the bottom there kind of shows how that operational to embodied, as our systems have got more energy efficient over time, embodied carbon, the green element, has become a bigger and bigger component of the total energy. So both are important for us to think about as a lift industry, the embodied carbon, the materiality of the equipment, plus the operation. We also have a very useful framework document here in the UK that was published by RICS, the Royal Institution of Chartered Surveyors. And this provides us with a methodology for assessing whole life carbon. And it provides us with a framework as a lift industry to hook into to say, okay, what does this mean for my product? And it talks about operational carbon and embodied carbon. And it creates this idea of expressing whole life carbon as kilograms of CO2 equivalent per square meter. So in a bigger building, you're going to have more lifts, you're going to have more embodied carbon, they're going to consume more energy. But if you're dividing by the net internal area of the building, you get some kind of quantum measurement. Carbon dioxide equivalent is an important thing. It's not CO2, it's CO2 equivalent. And that's a measure of all produced greenhouse gases associated with the system in terms of the amount of pure CO2 that would create the same amount of warming. Bit of a complex thing, but it's just trying to get apples for apples, I guess. If we look at embodied carbon and how the lift industry assesses embodied carbon at the moment, it uses something called the EPDs, Environmental Product Declarations. And these are an established framework. It's not directly related to the lift industry. It applies to many, many different systems. And it provides a range of data that includes embodied and operational carbon. It's third-party ratified. It's an independent objective assessment method. Why are lifts important? The data at the bottom here is for one of the projects that we've been working on in our business. And you can see lifts and conveyors, escalators, are there 8%. So it is significant. And it's something that we need to focus on as an industry. And actually, talking to our environmental engineers, maybe somewhat surprisingly, I was a little surprised when they said the lift industry is actually quite good at this, EPDs, better than some other industries, particularly lighting was quoted. And I would have thought lighting would have been way ahead, but no, apparently not. The lift industry has made great steps in terms of producing EPD data and publishing it. You can see there that it talks about particular processes that involve PCRs. And PCRs are a way, again, of trying to get an equitable way to assess EPD data. And in order to do that, it talks about this thing called a functional unit. And the functional unit is expressed there and is related to the load of the lift, plus some other elements such as the distance traveled, the number of trips per day, and the life cycle. So this starts to feel, and here's an example of what a functional unit calculation would look like. So if we took a 1,600 kilogram lift serving 9 floors over a travel of 40 meters, And if we assumed it had a service life of 20 years, operating 365 days a year, then our functional unit comes out to 5,400 ton-kilometers. So this is supposed to be an assessment to allow us to compare and contrast different lifts. When we actually try to do that, it starts to become a little bit problematic. So I took some data to try to say, okay, I've got a typical building, maybe a 10, 12-story building, and I'm going to put an MRL lift in it. Yeah. So I went away and tried to find some data on EPDs on MRL lifts. And you can see from the table here that the representative units from supplier 1, 2, and 3, 1,000 kilogram, 1.6 meter a second, yep, fine. But then supplier 2 could give me 1,000 kilogram, 1.6 meter a second, but only 8 stops. Yeah. Supplier 3, the data was service life of 25 years with the usage class of 3. Supplier 1 and 2, yeah, we're looking at service life of 20 years and the usage class of 4. Consequently, the functional units in that third column there are all different. So with me trying to say, well, which one's going to be the most environmentally friendly for my building, which is the ultimate goal of the EPD embodied carbon assessment process, I don't know. I'm confused. And I don't quite know how to address that at the moment. There may be others in the audience that we can talk over the next 2 days. I'd be really interested. I need to get moving. Operational carbon, the second element. Yeah. So we're key that we've got the ISO for assessing operational energy. I'll fly through this. We can talk a little bit more. It's a robust, established method, but it is quite simplistic by necessity. It applies to single lifts. It doesn't pick up regenerative drives. The actual standard references the fact that this may be up to 20% inaccurate. So all of a sudden, we're trying to predict and forecast actual energy consumption, and we've got a method that recognizes the fact that it is a mathematical assessment method that may be up to 20% inefficient. Doesn't seem, it seems a bit strange to me. It doesn't really talk about number of days. It's independent of demand. And therefore, for me, it feels like it's not as real world as maybe it could be. What it does allow us to do is this kind of assessment. So this is an example of a real project where we've got an assessment of theoretical energy consumption based on the ISO methodology. And you can see the number in the bottom right-hand corner, which is 7.6 kilowatt hours per square meter per year. So this is this base assessment of the operational energy of this system. Now, if we look at the 8 passenger lifts in this building, the green highlighted numbers, total energy consumption per day there of around 400 kilowatt hours using the ISO methodology. There's another way, though, that it feels to me we really ought to be exploring as an industry, which is to simulate it. We've done some calculations here utilizing Marilisa's proposed full-day demand template. So you can see in the top right-hand corner a demand template of incoming and outgoing traffic. We've got some electrical data here, which starts to pick up things like idle power, standby power, and regenerative drive according to the balance of the car, whether we're actually regenerating or consuming energy. And that can produce for us an energy consumption graph for the system, the 8 passenger lifts operating as an intelligent destination control group. And that number there, apologies, it may be a bit small, that total energy consumption number there is 375 kilowatt hours. So a significant reduction from the ISO. Whether one is better than the other, I'm not sure yet, but I do think we need to start discussing it as an industry and trying to refine and improve where we're going in terms of the accuracy of energy consumption. I think there's a clear need to focus on it. I think we've got some assessment methodologies available at the moment, but drawing robust conclusions is challenging, particularly in EPDs. Talking to our environmental guys, they talk about the need for EPDs to either have a greater range, but I think if we look at the lift industry and the sheer plethora of different configurations of lift equipment we can get, that's going to be really challenging. But whether there's a way of being able to derive EPD data from some fundamental milestone configurations that allows us to say, if that's EPD for 1,000 kilogram at 6 floors, what's it going to be for 1,600 kilograms at 15 floors? Because at the moment, they're selecting non-representative EPD data for these energy models. I think the operational energy assessments could be moved closer to predicted real-world demand, and maybe we're going to hear something from that about that from Dr. Peters in a moment. I think when we've talked about demand models for passenger lifts, I think, and there's a bit more in the paper about, yes, that's for passenger lifts. What's a demand model for a goods lift? What's a demand model for a firefighter's lift? I think as an industry, we need to develop those and agree a consistent approach. Thank you.